Number 32. It says triangle QRS is graphed on the set of axes below, and then it's asking us to do on the same set of axes graph and label triangle Q prime R prime S prime, the image of triangle QRS after a dilation with a scale factor of 3 halves centered at the origin. So there are many ways of doing it. You can count the boxes and all that stuff, but I like to do it by the rule. The rule is, which I wrote it here and I'm going to highlight it. When centered at the origin, multiply coordinates by the scale factors. So if I pick all my coordinates of Q, R, and S and I multiply them by the scale factor, I can get my new coordinates. So I'm multiplying 3 halves by each of the coordinates. So -2 times 3 halves, you can put that in your calculator, or you can do some mental math, is what? -3. And then 2 times 3 halves is 3. Similarly, R prime would be 3, 0, and S prime would be 6, comma 9. And I'm going to plot those. So -3, 3 is here, and then 3, 0 is here, and we're going to label them also. This is R prime, Q prime, and then this is my S prime, right? And I can just use my freehand, or if you have a ruler, and that is my triangle, right? So okay, so it's saying use slopes to explain why Q prime R prime is parallel to QR. So we can basically find the slopes of these two lines, and what do we know about parallel lines? They should have the same slope. So let's find the slope of QR. Look at this, the line's going down, and it is what? It's going down 2 over 4. So the slope of QR is -2 over 4, and if you simplify it is -1/2. And let's find the slope of Q prime R prime. It is going down 3 units. Since it's going down, it's -3 and over 6. You can count that, and that also simplifies to -1/2. So now what can I say? They both have same slopes, right? Same slopes. Therefore, these 3 dots mean therefore Q prime R prime is parallel to segment QR.
If you want to watch this part of the video, that's perfectly fine. If you want to skip ahead to see a more hands-on interaction of how to do the construction, perfectly fine with me, but I'm going to show both anyway. So 33 says, using a compass and straight edge, construct a regular hexagon inscribed in circle O below. Label it A, B, C, D, E, F. Leave all construction marks. So what I'm going to do is I'm going to take a compass and I need a straight edge. So what we do first, now you don't have to do this, but I prefer or like to draw a radius from O to the outside of the circle just so I know that I measured it correctly. So now I'm going to label this point over here, the intersection point. I'm going to call that point A. And what I'm going to do is I'm going to place my compass point on the center of the circle and measure to the length of the radius. What this will do is it will help me swing my compass around the circle to generate my arc tick marks. So I'm going to place my compass point on A, and I'm going to begin my construction process. I'm going to rotate it around, draw my tick mark, and then I repeat the process by moving the compass over here on this tick mark, and then do it again. And you just keep on going around until you stop back at point A. Now, in theory, you should end up back at point A, but sometimes that doesn't happen. Sometimes you are a little bit off, but that's okay if you are only a tad off from point A. It really doesn't make that much of a difference. I think that this one will be perfect. Oh, I am fantastic. So all of those points connect. That's fantastic. So I am going to now connect all of these points to create my hexagon, and I'm going to label it A, B, C, D, E, F. Great. So that's done. Then there's a follow-up question, and then I'll just go right to the other construction. It says, if chords FB and FC are drawn, which type of triangle, according to its angles, would triangle FBC be? And explain your answer. So we need to say to ourselves, well, FBC is right here. What type of triangle is that? Well, that is a right triangle, with angle B being your right angle, because this type of angle here, this is an inscribed angle. And by definition, an inscribed angle is 1/2 the arc it intercepts. This angle intercepts this right here. And that, ladies and gentlemen, is a semicircle. If an inscribed angle intersects a semicircle, then this angle must be a right angle. So therefore, your answer is going to be that triangle FBC is a right triangle. And it says explain your answer, right? So is a right, oops, I just spelled triangle wrong. Triangle. Because angle CBF is inscribed in a semicircle. Okay. At this point, I am now going to switch over to the construction with the hands-on compass. Okay, so this is question 33 from the January 2017 Regents exam. This is the construction, and this is hands-on for those who do not like the computer software that I use. And the question says, using a compass and straight edge, construct a regular hexagon inscribed in circle O below. Label it A, B, C, D, E, F. Leave all construction marks. So in order to construct a regular hexagon, it's actually the same process as to how to construct an equilateral triangle inscribed in a circle. So the first step that I usually like to do is I like to take my straight edge and I like to draw a radius from point O to one point on the circle, and this point over here is going to be my point A. Now, in order to construct a hexagon, I'm going to take my compass, place it on the center O, and measure the length of the radius to A. Now, it has to be spot on and it has to be precise. The reason why, the minute you start you start going around the circle, if you start to mess up along the way, your last arc is going to pass point A. We want it to go around and meet up at A once again. So, I'm going to place my compass point on point A, and I'm going to draw my first arc, like so. Now that arc is going to be a working arc for me by placing it on this new arc, and this will generate my next arc that I have over here. And you just continue the process around. So here's my next arc. Now, if you want to make sure that you're doing this right, look at this intersection point. Does it line up with the radius or the diameter? And in this case, it looks pretty good. It looks lined up well. So now I'm going to do it again. I'm going to place my compass point on this intersection point and repeat the process once more. And keep on going until you stop at point A. And in this case, that is really, really close to point A. So we completed this construction pretty well. So now I'm then going to draw a whole bunch of points around, and I'm going to label these points. Starting off with A, I'm going to label this B, C, D, E, and F, because it says that in the instructions. Now, in order to finish off this construction, I'm going to connect all of these vertices to construct a hexagon. So I'm going to connect line segment, or form line segment AB by connecting points A and B, and just continue the process all the way around. Now, keep in mind that a regular hexagon means that all sides are congruent to each other. And just based off of this construction, it looks pretty good that all of these sides are congruent to each other. And there you have regular hexagon A, B, C, D, E, F. Now, the follow-up question below says here, if chords FB and BC are drawn, which type of triangle, according to its angles, would triangle FBC be? And explain your answer. So the first thing that I'm going to do is I'm going to draw myself a triangle. Triangle FBC. So that's this triangle right over here. All right, that's the triangle that's from. So we're looking right in here. We're looking at that triangle. And it says, what type of triangle would this be? Well, triangle FBC would be a right triangle because angle B would be your right angle. The reason why is that this triangle, this angle is inscribed in a semicircle. So your answer is just going to be that triangle FBC is a right triangle because angle FBC is inscribed in a semicircle. Now remember, a semicircle has 180 degrees, and an inscribed arc is 1/2 the arc it intercepts, so this would be, of course, 90 degrees, because half of 180 degrees is, in fact, 90 degrees. And that's how you do that construction and that follow-up question. All right, so here's question number 34. And it says that a candle maker uses a mold to make candles like the one shown below. The height of the candle is 13 centimeters, and the circumference of the candle at its widest measure is 31.416 centimeters. Use modeling to approximate how much wax to the nearest cubic centimeter is needed to make this candle, and justify your answer. First and foremost, I like to draw in the picture. So we definitely know that this has to be a cone because it says that it is modeled by the cone. So I'm going to draw these things here, and I'm going to draw a circular, I'm going to draw a circular base like that, going around, and it has a height of 13. Okay. Now, we need to find the volume of this cone. But we have a problem. They tell us what the circumference is. We don't have the radius. However, we could use circumference to find the radius. So, circumference is equal to 2 pi r. They tell us that the circumference is 31.416. That's going to equal 2 pi r. Now, in order to solve for r, we just need to divide by 2 pi on each side. The 2 pi's cancel, and you get r is approximately equal to, let me go to my calculator. I use a TI Inspire, by the way. If you want this calculator, you could easily get it on my website. Just follow the link to Amazon. I think that's cheapest on Amazon. So 31.416 divided by 2 pi. Make sure pi is in the denominator, ladies and gents. You're getting 5.0000. All right, so that kind of indicates to me that the radius is 5. So you don't have to write all those decimals, so you could just stop at 5 because it's so, all of those decimals are so small that it's kind of irrelevant. Now, you need to find the volume of the cone. The volume of a cone is 1/3 pi r squared times the height. So the volume is equal to 1/3 pi. Now the radius is going to be 5 squared times the height of, looks like 13. So the volume of this cone is, let's see, if we type that into our calculator, that's going to be 1/3 times pi times 5 squared times the height of 13. And that is going to be 340. And that is rounded to the nearest cubic centimeter. So that is the volume of the cone, and that is the amount of wax that we need.